Hi guys, good morning everybody. So this video is completely designed for Kubernetes scenario-based interview questions. So first of all, we are going through the scenario-based interview questions. So first of all, I would like to tell a high level about Kubernetes. What do you mean by Kubernetes? Kubernetes is it's a system. I can say it's an open source system which is designed for which is used for automatic deployments and automatic scaling, and and you have to maintain the containerization applications. Okay, whatever the applications are get containerized by maybe the Docker containers, the ECS or ACS, like so whatever the containerization applications. So we have the Kubernetes, we need to have to maintain those containerized applications, and we need to automate the deployments, and we need to automate the scaling process as well. So it is one of the most prominent and significant tool in the world across the globe. Currently, it is hot in the market. So everybody, every organization, and every sector, it is they are using the Kubernetes. So this is one of currently it plays one of the major important role in our in everybody's life, most probably in the IT industry and in the current scenario in the current world as well. So it is mostly useful to maintain a containerized applications. It is used for containerized orchestration. Okay, so I can give an example. No, so nowadays, every organization, every project, every clients, they are asking to migrate their applications, whatever the legacy applications, whatever the already running applications, or like steady state applications, all the applications they want to migrate those applications from on-premise to cloud. Okay, and also before going to this thing, the Kubernetes can be useful, can be implemented at on-premise as well, at virtual as well, and even in the cloud infrastructure as well. But nowadays, we know that most of the migrations are going to place on the cloud, and the Kubernetes concept is going to establish to launch to implement on AWS or Azure or Google Cloud systems platforms, I can say. So most of this is this plays very important role in this making it into microservices. For suppose we can place it in AWS as an EKS cluster with Kubernetes, and we can place in Azure as an EKS cluster with Kubernetes, and we have Google GKE, Google Kubernetes. Okay, so all the three are they are vastly using it across the globe and across the organizations. So it plays a very important role, and we have more important jobs that we can get it, and we need to have to be um, get knowledge on this Kubernetes. So this video is completely for the people who are going to face the interviews. So I have covered most of the topics at a high level, not the high level, like exact scenario. So the networking side, the scaling side, the monitoring side, the communication side, all these things inside the Kubernetes. Okay, let's go through one by one in the slide. Okay, see, let me put in the presentation mode. See, suppose your application is deployed in Kubernetes. Suppose your application is already deployed in the Kubernetes, and which is having a high traffic load. How would you scale the application to handle the high load? See, generally, whenever your interviewer asks you this kind of question, we firstly goes to HPA. It should be the perfect match, and it is the mostly using concept, that HPA, horizontal pod auto scaling. It is more effective, everybody using this HPA. So before that, so we have a lot of options that we can, we have horizontal pod scaling, we have cluster auto scaling here, and we have vertical pod auto scaler or manual scale deployment. So we never go for the manual scale deployment. So nobody is going for that. We can do it whether it's a requirement from the client, or we use load testing or monitoring. Okay, monitoring is fine. Or you have to optimize the app performance. So a lot of things are there. But the main important thing that we need to learn, and we need to be very perfect in horizontal pod auto scaling. See, to handle the high traffic load in Kubernetes deployed application, you can scale it effectively, because due to the high traffic, the something has to be scaled. inside that. So scaling in the sense is kind of auto scaling. It's kind of auto scaling mechanism. So we have give the desired value for that. So it will scale accordingly to across the nodes. So see the first one, that auto scaling, or here the auto scaling. Okay, the auto scaling port auto scaling. So HPA. So automatically adds or removes ports based upon the CPU memory or custom metrics. Based upon the CPU memory or a custom matrix. So if the CPU memory is crosses more than the threshold, initially we have to set up C in this kubectl autoscale deployment name, current CPU percent 50, minimum is 2 ports has to be one has to be there, and and the max is 10, like we have to give like this by using this kubectl autoscale command. So if you put the threshold suppose 85 in the CPU percent, and if the CPU percent is cost more than 85, the CPU usage is crossing 85, so it automatically launches one more pod, because it might crash if the memory is crossing the threshold value. Is something we have given some custom metrics like that, I say 85 or 90 like that. Whenever it crosses the given values, if the CPU memory is CPU usage is high or memory is high, it will process. Then it will give the alert by our monitoring tools that we have selected. We have we have attached. We have given the agent to our pods. So definitely it has to, because it is one of the intelligent platform. It has to observe. It has to see. Okay, this for this pod the CPU is getting high, so it is keep getting high. It will launch one more pod in. This automatic deployment launchpad is happening, and one more predictability. It will scale the request. It will scale the traffic that comes from the outside the world to the cluster at the cluster Kubernetes cluster wide. So it will automatically balance the traffic. This is one of the most important topic that HPA. You guys need to tell about the HPA whenever the question raises from this one. This is a very important question. So wherever you go, whenever you go to any Kubernetes, like I can say DevOps interviews maybe, right? The Kubernetes should be, there is a deployment tool. It's an automated deployment tool, automated scaling tool, orchestration tool as well. So definitely this question should comes up, and you have to explain this. And by using the CTL command, you can get this. And the most thing is, like, we have to go for the AML file. Explain, please explain whenever the interviewer. So first of all, tell about the kubectl. You can say using the kubectl, we can automate and we can give the threshold values. We can minimum and max values accordingly. It will take it will install, launch the pods. It will decommission the pods. It will source the traffic to the healthy pods or non-healthy pods, like that. And also, if interviewer asks you to write an AML file, it should be very easy, man. Guys, we have to write the AML script for HPA. So we have a default manifest AML file. You guys already know. Then we can you can give the see, like give the app version, autoscaling V2, or we have to give the kind, horizontal pod autoscaler, and then we have to give the metadata, like so the name of it, and we have to give the specifications. So if you go this kind, deployment is there, and your deployment name is there, and you can give how many replicas you want. Minimum is 2 replicas and maximum is 10 replicas. And you have to give the metrics. Okay, what kind of metrics we have to take into consideration for launching the pod replicas whenever there is a high traffic. So that's it. The type is the resource, and we have named the resource name is CPU, and the type is CPU's utilization. And so if you give the average utilization is 60, I can give here, I give here 60. You can give at least 70, 75 like that. It's a threshold that we have to go. According to that, the HPA will balance the traffic on the pods. It's a simple, straightforward question. And the manifest AML file, writing a manifest AML file for a particular concept in Kubernetes is also very simple, guys. So this question is very simple for you. So when first you get a question from the interviewer, we can tell the first thing is HPA. That is the first thing. Whatever I have explained to you, please note it down. It should be very helpful for you guys. And coming to this second one, this is a cluster autoscaler. You do know this cluster autoscaler, because the pods cannot be scheduled due to lack of resources. Maybe in the Kubernetes, because most of these things, like whenever we have deployed this Kubernetes cluster, into our available, most prominent available cloud systems, cloud platforms like AWS, GCP, and Azure. Okay, so it must be configured at the customer level. There should be have those cloud systems platforms they have their cloud provider auto scaling groups automatically is there. So there we have to configure. This is one of the cluster auto scale system. It can be configured at the cloud system level, but the HP is yet internal to the Kubernetes. So this is the second way of doing it. And third, there is like we have an horizontal, pod auto scaling that we have a vertical pod auto scaler as well, which is an option. Like see, most of all, I see that I know I have gone for many interviews and I have seen many situations even in the projects when I am working in many of the projects with Kubernetes and all. So I don't see that vertical pod because nobody prefer vertical pod autoscaler thing because it may be like I so that's why I kept as an optional maybe it kind of be because it can be done. It can be done. See, if you see adjust, it will adjust the CPU memory request for pod dynamically based upon the usage. Useful for applications with variable resource needs, but less effective for sudden. If there is a sudden spike, suppose I have an e-commerce system of I am using e-commerce system like Flipkart or Amazon. If there is an Christmas or if there is an Diwali or something like so, so definitely it gives a sudden spike. So when you compare to the vertical pod autoscaler, we so I always gives an option you guys to go ahead with the horizontal only. Don't go for vertical. It should not be much effective than horizontal. Okay, that is the one. So you have to explain one by one. Okay, definitely if you explain the HPF first at first time, then the interviewer will get impressed on you. He will get he or she then definitely get impressed on you. So the fourth one is manually scale deployment. So manual scale, I don't prefer the manual scale deployment because so everything is so getting automated here, and we have to define the automation here by using a kubectl command or by using you have to write some manifest YAML file to automate it automatically. So we are not here to do every time to do manually, right? See here it is saying for the immediate response, kubectl scale deployment, if deployment like replicas, useful as quick fix while tuning HPA. So when there is something happen while we are triaging the issue, while we have to run this, giving these replicas, then we can run it like that. But most probably it's not useful, I can say. Okay, it depends upon the project again. I am saying. And the fifth one is use load testing and monitoring. So definitely this is only one of the important thing, right? Whenever there is a CPU hike, whenever there is a memory hike, whenever there is a disk hike, whatever it is, like we need to get notified, right? So how will we get notified? So for that we have to get analyze the metrics of the each pod or each node, each system object within the Kubernetes. Like for that we have Prometheus because those are very compatible. The Prometheus and Grafana both with the Kubernetes dashboard. Also we can use the K6 JMeter or Locaso, but you guys most hardly prominently heard about this Prometheus and Grafana or Kubernetes dashboard. You can say within the Kubernetes we have a Kubernetes dashboard. But most of them they can prefer because they are use the Kubernetes dashboard within that because they might be a compromisability within them. So definitely we have to take the external things like Prometheus and Grafana and we have to configure with the Kubernetes and it will give the alerts and notification to us to observe the CPU memory or network metrics to determine any bottlenecks will be there. So all these things. And this, the sixth one is the optimize application performance. How you optimize application performance? See, sometimes the fix is not more pods but better code. Sometimes because everything is fine from the Kubernetes and the pods and all these things. There should be something happen in the code. Maybe so there is some latency. We have to optimize the response time and we have to add the Redis cache. There is something happened at the cache level. Any if you have any streaming kind of Kafka or RabbitMQ like that, see if there is any queues that got struck and all those things. So we have to see about this and we have to because these are to be get up. So sometimes up to the fifth branch you can do everything within the Kubernetes and within the monitoring tools, but there should be something there in the code as well. So we need to encounter because before we are going to set up a Kubernetes cluster for a new environment or for a new application migration onto any of the clouds. These are the important things we need to take taken care into the consideration. to take care into the consideration. Okay, and the sixth point is that is again that we need to work with the developers. Is there any automation required at the code, because this some page is not coming up, it is giving the latency. There might be some issue at the code, there might be some smart compatibility need to be changed according to the functionality within the code level. So all this is to be taken care. So whatever I explained to you the first question, this is the main important question. It will cover most of all the questions. So every question will comes up from this topic itself only. This is one of the main important thing. Guys, please remember and please take notes from my lesson, and you will be the best guy to answer the questions in our interview. Okay. So going to the second question. So what if a team needs to deploy a web application? Simple. Yeah, sir. Here, whatever I am saying, everything is related to the first question, I can say. Simple. Because no one can ask outside of this. Your team needs to deploy web application with multiple replicas to ensure high availability. How would you design and deploy it in Kubernetes? Do you guys know what do you mean by high availability? Because your application is deployed on a Kubernetes cluster with the help of Kubernetes orchestration. So, and my application should be available on 365 days and 24/7 and 365 days. It should be highly available. I'm not going to take any downtime at any cost, even during the enhancements, even during the deployments, or even during the maintenance, whatever it is. So how can you achieve this? First thing is, like, whenever you are using Kubernetes, we can achieve is by deployment to manage by using a application pods. And we have to clearly specify the number of replicas in the deployment manifest, which ensure the high availability. Because the same thing here. If in the first case the traffic holds on, if something goes down, it will autoscale, it will launch a new pod, and all those things is fine. Now this is also same kind of thing. You have to give maximum more pods, no more replicas. Ensure the 3 pods are always running. Suppose I want to see the highlighted one here in the yellow. I put 3 replicas. Based upon, you have to estimate the user base for your application. I can say that whenever there is kind of a for school, for college, for the university application which has been developed in Kubernetes, whenever there is a results time, there should be high spikes. So we need to update the manifest manifest within the pods. Okay, according to that, we can estimate that, and we can put 5 replicas or 6 replicas to balance the load. So definitely it will give the high availability for the customers without any downtime. Suppose if my application is very critical, suppose my application is a banking application, or suppose it is an insurance application, or suppose it is a healthcare application, whatever it is. I want to make all these type of sectors to be high available whole day and night. So whole 24 hours and 365 days. So according to that, we have to configure. We have to give the replica sets over here. And the third one, you see, use a service type of cluster API to expose the pods internally, if only used within the cluster, or type load balancer for external access. So first of all, within the cluster, we have to maintain the intercommunicable communication possible within the pods internally. We have to check it how we can have to networkingly they will be communicate with each other, and if they are fine, then definitely we have a load balancer on the top of that. We can place it for the external access. We can take the load balancer according to our where we have deployed Kubernetes, whether it's AWS, whether it's GCP or Azure. Okay, that's it for the second question. So going for the third question. Suppose your application requires a persistent storage for user uploaded content. User is okay. How would you configure storage in Kubernetes? Suppose you have an application and you are the DevOps engineer and you have created the Kubernetes cluster, and you have migrated the application, you have launched a new application, and you are keep deploying the application on Kubernetes. Fine, it's still going on. It's a continuous steady state. That's fine. Now you need to have because you have one of the suppose in your application you have one of the functionality in your application. Okay, suppose I can give you an example for you guys. Suppose there is an HDFC bank or an ICICI bank. Go for the banking sector, maybe. Okay, And once you log in into the ICICI Bank and you want to take an account, or you want to upload some your data, suppose a photo you need to change, or you need to change the address, or you need to change the city, or you need to change the gender, whatever it is like. So they have to capture some data. So the data can be so the function. I'm just saying about the functionality, whether it is not like what I have said, what I am telling to you in that ICSS side. Just I am taking the example. That's it. Suppose I am getting data. Suppose I am getting a photos, images. I'm getting passport size images. I'm getting a address formats, a lot of formats. It's keep getting on. The objects are keep getting on, and my storage is not persistent over here. We have to take the load of it, and I need to have to have separate storage for that. What is the possibility for that? Your application, suppose the answer is we back your PV persistent volume, back your persistent volume with storage solutions such as, because already we have Kubernetes is on AWS maybe, and GKS, and one FS mount or something Azure like that. So we need to make sure of before launching it for every pod we have to give the persistent volumes by using your AWS EBS and the Google persistent disk or NFS mount. Once you have taken the alteration of those things, and we need to attach persistent volume claim to the pod. We need to attach that storage to your pod. You need to attach the PVC. Here see, you need to attach the PVC to the pod in the application YAML manifest file. Again, the same thing. Here are the examples showing how to do this pod definition. Okay. See, I will assume you to already have a PVC named by your PVC. Like definitely there should be a PVC that should be attached for your pod, and we have to give the persistent volume assumption for your pod to store the content, to store for this persistent storage. Okay, like that, the same kind, the same thing. The application version of it, the kind, the main, the pod, the container. You have to give the container, name it, and a volume mounts. Okay, mount path inside the container, my storage. Like that, we have to give in claim my PVC. So I am not putting everything over here. So if you go and see in a Google, you can search in Google, you will get a better idea of that. But just I am explaining you to how to explain to the interviewer. It's very easy for you guys. So definitely all the time whenever you configure the storage thing, you have to take into consideration as the persistent volume that should be attached to the pod to maintain the persistent storage for your particular application, particular pod application, for particular pod for your application. So everything it should be balanced. Suppose I have again the replicas is for the replicas for 4 replicas or 5 replicas. We have to take into consideration. We have to persist the volumes. We have to maintain the persistent volumes, the storage to each pod. You have to attach the PVC to the pod by using this manifest YAML file. If they want, you can write this YAML file like, see, if you no need to worry guys. So all the type of syntax, all the type of appearance should be the same for the manifest YAML file in the Kubernetes. Just you have to update what exactly you want. Is the name your storage. If your storage is there, you need to update is my storage like that, storage container. If it is HPA, we have to clearly mention that, right? I have shown it before. Horizontal pod auto scaling, like that. That's it. This is one of the important questions they might ask you. And this is the next question. Okay. So it should be long, but no need to worry, guys. It's a simple. If you see, it's very easy for you, point to point. Suppose if you do troubleshoot a network issue in a cluster. Suppose there is a cluster is already set up by you. Okay, and you see there might be a network issue that might happen in your cluster because there is not communication is not happening within pods. There should be so particular routing is not happening. There is no separate particular role balance is not happening. There is something missing, some network rules inside that cluster, all those things. By triaging that, if you observe any kind of a queue proxy logs, because this is very important question, then this is very repetitive question that will be asking by most of the interviewers in from most of the organizations. If you observe any queue proxy logs, Okay, and you have to identify, you have to know what you mean by proxy logs inside, and what is the use of it. What is the main purpose of proxy? They will not ask, maybe they will not ask question like this. They can ask you, what is, can you please explain about proxy, what it is, and what is the importance of it. So before telling all the possible scenarios for the network issue, you have to answer him or her or them. Like, proxy is a networking component. It's one of the main networking component in our Kubernetes. It will run on every node, which means node in the sense it's a system. It's a virtual machine, I can say. It will run on every node. Inside a node, we have a number of pods. And inside a pod, we have a number of containers. One or many containers will be there. Right. So the proxy is a networking component that runs on every node in a Kubernetes cluster. His primary job is to handle the networking traffic routing. Network traffic routing. See, before that we have discussed is the load balancing, the auto scaling, okay, all those things. The how it is going to happen? We need to have a network load balancer as well. Sorry, not network load balancer. It should be there. We need to have a network rules should be applied. It's one of the networking component, the proxy. It will handles all the network traffic routing issues, routing scenarios inside the Kubernetes services. Like that, these are all the things I have mentioned here. 1 to 5. One is service routing. Kubernetes services, like we have a cluster IP, right? We have a node port, we have a load balancer. It will provide the stable virtual IPs for these things. And second, proxy routes the traffic from the service IP to the actual backend ports. It will route the service IPs. Whenever there is a service request comes from the external, it will causes the load balancer, it will causes the DNS, calls the load balancer, then it will touches the cluster. From there, the service IP, it will route the service IP to the actual backend ports, like the endpoints we can say. Like coming to the load balancing, same concept that we have already described. Here the main thing is internally the proxy distributed the traffic among the pods. Because if a service has a multiple pods behind it, service request comes to the different pods, suppose like so. Proxy distributed traffic among them. Okay, it uses a simple. You guys know the scheduling technologies like first in first out, first in first search, like round robin, binary tree. So many of the algorithms like that. It inside that proxy it will follow. It will maintain the round robin technology, round robin algorithm to distribute the traffic across the nodes, across the ports. Coming to the network rules management, the same thing. The proxy setups and maintains IP tables because definitely if the proxy is maintaining the distributing the traffic and enabling the traffic and load balancing the traffic and all those things, definitely it has to be have to set up and maintain the IP route tables and IPS rules as well. It has predefined inside that proxy within the Kubernetes cluster. And these rules direct network traffic to the correct pod based upon the service definitions. Because suppose I have a microservices, suppose I have one service that is, I have a few services I kept in one pod, I have a few services I kept on one pod. Okay, for each pod there is a replica set for so I can put a 3 replica sets for few services inside within the pods. So based upon service pod, the traffic it has to be identified. The particular service has to be routed to the particular pod by taking the consideration as the service definitions. I think you got it, guys. And the fourth one is node port handling. Same thing, the port services. Here it comes onto the port services. There is a service definitions. Port service has the proxy listens out to the port on every node. Like as we have a normal networking way. If you guys have minimum networking knowledge, then it should be very easy to understand how the proxy handles all these networking issues, networking scenarios. Sorry, it's not issues, it's scenarios based upon the definitions, based upon the traffic, based upon the IPs, based upon the ports, like that. See, if suppose even if the pod is not on the node, proxy forwards a request to the correct one. So see how intelligent it is. within the networking terminology. You guys have to think on it. See, whatever I'm explaining to you, it should be easy for you guys. Please take a notes, should be handy for you guys, and you have to prepare yourself before going to interview. They will not cross, they will not go out of these questions because almost all I have covered it. I am explaining very clearly to you guys. Okay, so coming to the last one, the dynamic updates. Okay, the Kubernetes always watches the API changes in services and the endpoints. Always it monitor the API for any changes that is happening in the services. It will automatically updates the routing rules whenever ports are added or removed or service change. Definitely. Coming to the auto-scaling concept, suppose the pod is got crashed out during the high CPU or high memory utilization. Definitely it will, the auto-scaling will launch a new pod. So definitely it will always, the crew proxy is always new to monitoring whenever there is a pods, new pods added or old pods demished, or the routing rules has to be updated. It will update the routing rules automatically whenever there is a new pods are created and there is any service change happen. So this is one of the, see, because you guys go through all these 5 points. So these 5 points are more important for the queue proxy. That is very good for you guys. Okay. Next. If I want to set up a high availability Kubernetes cluster, explain what all recommendations that you consider, because I have explained already about the high availability. Consider to set up high availability. So what all we consider? The control plane redundancy. So we have the redundant kind of, so I can explain one by one all these things. Okay, 1 second guys. I have noted down all the points clearly. Okay, here see, control plane redundancy. See, it's the same thing, sir. So minimum we have 3 nodes, we have to put it to maintain the quorum in EC3. Okay, these nodes run the Kubernetes API server and the control manager, scheduler and ECTD, use an external ECTD cluster. What do you mean by ECTD? What do you mean by ECT high availability? It's kind of a key store. See, ECT is a key store value used by Kubernetes for all cluster data. Whatever, because usually the configure that whenever we have to give it the ECT numbers for the replicas, like how many pods that we have to configure whenever there is a high traffic. So if you want to maintain the high availability, we need to maintain 3 to 5 like this. Okay, so 3, 5, 7, 9 like that. So etcd is a kind of a key store within the Kubernetes to maintain all the metadata, all the data about the data and all the data as well, like the cluster data, the replica data. So every data should be stored in the etcd. Because the Kubernetes has to be take the reference and it will have to cross check every time to see the high availability of the cluster. And the third thing is high availability worker nodes, load balancer for API service. That definitely we have already explained it. We have to give the load balancer, API service and high availability worker nodes and use a reliable CNI NSA. So automated health checks and self-healing, I can say. Because we have covered all these things, automated health checks. What is this? If you go for the automated health healing, what is this? Use liveliness and the readiness probes on all your application pods. We need to maintain the pods should be live and ready whenever there is a high traffic. I want to maintain a high availability. I want to maintain a best networking communication within the pods. I want to be accessible within the pods to the external world. For this, we have to do the liveliness check and the readiness checks. So we need to enable the liveliness probes and the readiness probes on all the application pods. And also coming to this, we have to ensure the cluster autoscaler and the queue proxy are configured correctly. Definitely, the cluster autoscaler you have to configure perfectly. It have to be auto scaled. The cluster should be auto scaled, and the top of the cluster it should be auto scaled. It should be load balancer, and we need to make check every time. That is kind of a health checks. Suppose every morning we have to give the health checks report. We have to automate the health checks. It will go on each thing whether the pods, all the pods are getting live or not, all the pods are ready or not, and the cluster autoscaling is working correctly or not, and the queue proxy what we have discussed just now, right? So whether the queue proxy is configured correctly is not, because the queue proxy is very important thing that we have to check every day. Maybe some network glitches might be happen, maybe some maintenance may be happen. So if some other team is doing some maintenance, we don't identify that. And also within the Kubernetes, we have to we can automate it by using the script here. The script will check all the queue proxy settings within that. How the network to routing tables is fine, how it is routing it, how the customer IPs is there. See, service routing is fine, you have to check it. And load balancing is fine. Networking rules management maintains the IP table rules IPS, and node ports listening is correctly or not. So all these things we need to check it. Okay. So we need to, so see, coming to the 7th point for the cloud provider best practices. It's kind of multiple zones, multiple regions. Okay. So if your code or if your application is operating in multiple zones, like it's not a one zone. Suppose if you are taking an Azure or AWS or GCA, GK, AKS or EKS or GK, it should, suppose our application has to be in multiple. If the client, if our organization wants to put in the multiple zones, not only a single zone. So it's one of the, because in this scenario, the 7th point completely the highlighting the 7th point in this scenario, why we prefer the multiple zones. It's completely depends upon the customer. Customer needs, the client needs. Why? Suppose I have a client. Simple guys, I have a client. Currently, I am working in one of the client. The client is taken two regions of AWS. Okay, not only one reason, because for the disaster recovery and also the high availability. The first thing is high availability that we are discussing currently right now. For the high availability, even though we have only one region, within one region we have multiple zones. That is also fine enough. But I have more money and I have more investors are coming into my business. I want to maintain and I want to make them happy. I want to make them happy. I don't want to discourage them by giving a downtime of my application by using this Kubernetes cluster inside the AWS or inside the Azure, inside GCP. I have to take in multiple regions. It again depends upon clearly saying that taking multiple regions is not a simple thing. It's a high cost. It's a high cost estimation, high cost effectiveness. It's up to their financial needs of a customer. If they want, then we can set up the cluster on multiple zones. Suppose in India, in AWS, I know that there is a Hyderabad region is there and there is a Mumbai region is. If my clients want to set up in Mumbai and Hyderabad both, I can set up the EKS cluster in a Mumbai region and Hyderabad region as well. For the greater visibility, for the high availability, with zero downtime and all, they will say all these things. It's up to them. And most important also, coming to this topic, apart from the high availability, by making a different regions, it should be always good whenever there is a disaster recovery happens. Or else you can maintain your private cloud on-premise, private cloud or your on-premise. You don't want to decommission your on-premise infrastructure. At the same time, you have to maintain the cloud infrastructure as well. Whenever something happens, nobody can do anything, right? So that is one of the best practices. And also, so that's why I put here, if applicable, completely. Okay. And coming to this 8th point, monitoring and logging. The same thing we already discussed it. We have to monitor the Kubernetes cluster by using the Prometheus Grafana, a different Fluent or Fluent bit like that. We have to monitor the health of the control plane and application workflows all the time. Every morning we have to check the monitoring and we have to keep checking the logging and all those things. And coming, so I already explained this disaster recovery and backup like this. What is the disaster recovery? When there is any natural calamity happens and when there is an automatic shutdown happens in one of the data center, whenever there is a fire action happens in our data center. The most important thing in this is etc, because it always we need to take, because it contains the data about you, the whole Kubernetes cluster. It contains the data about the Kubernetes cluster, how many reports are there, how many scaling is there, what kind of networking techniques are there. It will keep holds on the queue proxy settings, networking settings, monitoring settings, the logging settings, everything. It stores everything in etcd. It's a key store. It maintains all the data about the Kubernetes, your Kubernetes cluster. So from that, we need to take a regular backup. We need to take the snapshot regularly. For this, if you are having the AWS cluster, you can use a Lambda function. We have to write the script. You need to take the backups from etcd every time. That should be good for you. That is one of the best automation technique that you have used, and you have to tell them to the interviewer as well. You can write down. See, why can't we use Velero and all those things? Why? You can write a simple script and you can schedule it. Every day after off business hour at the midnight before 12, it will take the snapshot and it will store into some S3 or some storage level, or it will give you through a mail like that, and we can store on our client SharePoint like that. So it should be a good practice to do that every time. And the 10th one is security and access control. Same. Okay. All these are the 10 things you have to tell them. Simple, guys. Very simple. You have to tell them simply, because I am explaining in depth for you guys to understand. But you can go at a high level. If they ask for a particular thing, then you can tell them. Okay, how to tell that? Suppose if I want to, okay, if they ask you a separate, so what do you mean by internal load balancing? If they ask you, so let me get to the question first. You have multiple microservices that need to communicate with each other. Definitely, my application is having multiple microservices. So suppose my application is having 100 functionalities. I am dividing the 100 functionalities, 100 are the major functionalities. Inside this, there is sub functionalities. I am not going to, get into more chunks inside the microservices. For the 100 functionalities, I can make it to 100 microservices. Right? I can take one pod, I can put 10 microservices in a pod, or 10 in another pod. Accordingly, I can create the pods in the cluster. Okay, that is the thing. So here you have multiple microservices that needs to communicate with each other. How would you handle inter-service communication in a Kubernetes cluster? So inside the Kubernetes cluster, the pods to be intercommunicated with each other. How it is going to be happen? And you tell like this, like see, in Kubernetes cluster, there is an inter-service communication is a key architectural consideration. It's one of the key architectural consideration for the microservices based application. I told you, right? Microservices. For the microservices based application, especially for the microservices based application, every service has to be intercommunicated. Here, how it can be handled effectively in Kubernetes. What are the scenarios? What are the implementation that we need to do to make it possible? The first thing is service discovery and DNS, communication mechanisms, internal loading balancing, API gateway and service mesh, authentication and authorization, and observability. These 6 are the important steps that we need to. Okay, let's go for explaining one by one. See this. In a Kubernetes cluster, the inter-service communication that we discussed, right? So all these 3 are explaining. So service discovery and DNS. We have an inbuilt-in discovery in Kubernetes that provides an internal DNS system. See, each service gets a DNS name, like for example, a service name inventory, the namespace shop is available via like this. Pods communicate using the service name instead of a hard-coded IPs. Hard-coded IPs is already there. Why? It should be traffic should be writing through IP search, but the communication should be happening by use of service name. You have to give the DNS name. Service gets a DNS name. Okay, from DNS name it has to communicate by using the service name, because we have to give the service discovery and the DNS. That is one technique. The other is communication mechanism, like we have HTTP and REST API, ABS or GCP. These are the two techniques. And we have the message queues like this RabbitMQ. Most I can prefer RabbitMQ. That should be fine. And coming to the internal load balancing, we have to give the load balancer. Yeah, simple by using IP cluster IP. Kubernetes services provide load balancing across multiple pod replicas. Simple. The kind is a service. We can get the port by we can give write the YAML for it will communicate with internal servicing. It will do it. Internal load balancing. But internal load balance is not good. So we are not especially good in that internal load balance is not there required. But because we have the queue proxy and everything, it will communicate it through cluster IP, through networking, through route tables, everything it will do it automatically. That's fine. But if you want, you can make it as internal load balancing as well. Okay. And but this is the best. This is again I am telling it depends upon the requirement from the client. See, sir, you can use service mesh or API gateway. You guys know API gateway example Nginx, issue ingress. You know ingress, right? So we need to route the external request to the internal request services. How? By using authentication, rate limiting. Rate limiting is not fine. So service to request routing, authentication of this the request routing. By using the DNS, you can say by using the DNS discovery service discovery using DNS as the service name, domain name service as the service name like. And authentication or authorization. So the kind of a token authentication like that, service to service authentication. We can provide. It's a bit kind of a token, but this is a very good thing. It's a kind of a token authentication that should be happening between service to service. This is also has to be happen, and we can authenticate itself as well. If your interviewer asks you how you if you tell that authentication or authorization, and if you explain about this JW tokens or auth 2, or if you just service mesh or shared table, they definitely ask that how you implement this one. See guys, please copy this one and type it in our Google and get it. It's a simple thing how you communicate, how you authenticate it. No need to worry. Some people might want to have to service mesh. How the service mesh will be happening? How it will be implemented? Through MLTS. You guys know through MLTS? He has see the service mesh. Mutual transaction layer service protocol. This is very good. It's a two-way handshake to be happening. It's a mutual TLS. Mutual transport layer service. Then only the communication is happening and it's secure. Or also we can control the traffic inside the canary or blue grid deployments because see you guys might know the deployments. We have two kinds of deployments, blue grid or canary. Suppose if you go for AWS or not, there we have to give the Kubernetes as the blue green deployment where we can control the traffic over there. But I don't see the status and timeouts and grid circuit breakers. It's the next level one, but I don't know much about this. Okay, but these two are the mutual TLS is fine using the service mesh, and the traffic control is also by using the blue green deployments or the canary deployments. Again, the observability. You guys know, observability means the monitoring. Because I can prefer all the time less than ELK or local logs like we can prefer Grafana and Prometheus. This should be very good. These tools are very intelligent and these tools are very fine. It will give the application not only application performance, it will go the transaction level as well for the application functionalities. Okay, okay, and we are in this one, and we have I think one more. Yeah. Suppose you have a multiple. So this is the last question. Like you have a multiple microservices that needs to communicate with each other. I think this is already done, right? Sorry, guys. I think done. Yeah, this is the final one. Suppose if you are observing an increase in latency in our application, how would you diagnose a network latency issues within the Kubernetes cluster? Definitely, it's a network problem. What do you mean by increase in latency? What do you mean by latency? Suppose if there is a website that got deployed in Kubernetes cluster. Inside the website, I have clicked on one of the functionality. It is taking some time. We have given some rendering time. It's a kind of a microseconds. It will show you the page, another page. It will show you the pop-up. It will give you the dialog box like that. But if it is taking more than that, it's a latency. When if you are getting to retrieve a data from your website, there might be some code issue. There might be some long procedure is running to get to fetch the records from the database and give it to the backend application, then to your website. So these are all the many things that are going to be happen. There are lot of latency issues. Might be the pod communication might be not good. Maybe there is some network latency, DNS latency, all these things. There is service mesh latency. See, so all these are the maybe these are all the things may be affected. Let me go through this one by one. Slide 10. Okay. See, diagnosing a diagnosing a network latency issues in Kubernetes cluster requires a structured approach. Identifying whether the problem is in the application layer, I already told you guys. Application layer, whether there is a code or the database layer, application layer or a network layer. You guys know about the OS configuration, right? Operating system configuration. We have different type of network layers, different type of layers. Application layer, network layer, transport layer, service. There are so many things are there like that. We have to identify the problem, whether it is a problem in an application itself or a networking or a service discovery, whether the service is correct, inter-service communication is happening correctly or not, or a resource saturation. Maybe something the resource is going to be saturated, that is content, that means like the pod is not coming up, or there is a failure in the node like that. So coming to the step-by-step guide where first thing is we have to identify the affected services. Why this is latency is happening? Why it is taking a lot of time? First affected services is determine. We have to determine which services or endpoints are experiencing latency. Where there is a lag is happening. Which services are taking time. I am again telling that services is nothing but a functionality of a separate application. We are dividing the functionality into services, into microservices. One functionality into different microservices, or many functionalities into many services, or one services into many functionalities. So it depends upon if you guys gets worked with developers, work during the cluster management on all those things, you will get to know very well how all the functionalities are divided into microservices and micro one or many like that, or many. Okay, that's okay. The identify the affected services like by using metrics. You have the Prothemus and Grafana. By using these two, we can identify. Okay, we will get the transactional level, we will get the functionality level, we will get the networking level as well. Application level, we can able to see whether by using Prometheus and Grafana. Now check pod-to-pod network performance. You have to check the pod-to-pod network performance. Okay. By using this command kubectlx pod, you have to ping the pod A and pod B like this. Or you can use netperf iperf for work to test the bandwidth and the latency. Okay, see this iperf3, or I can see the pod IP. You have to give the pod IP, and I give the IP number of the pod, how it is doing and all. We have to check the pod to pod network performance by using kubectl, by using netperf or iperf like that. You can tell this. Definitely they will ask you how you check the pod to pod network performance. If you find a latency in getting the Kubernetes cluster, then how you check it? What are the different scenarios that you have to play to identify the network latency? That is one, they identify the affected services by using a Prometheus and Grafana, because we have to check the logging system and where it is lagging. If you find any issues over there, we have to tell them like that. Next, check the pod to pod network communication. Is it happening perfectly or not? Within the defined time or not? How the performance? Next, inspect Kubernetes network plugins. We have CNA, CSI. CNA plugins are fine or not? Simple here. Everything will be get by using the kubectl logs type in kubesec, the CNI pod and the pod name. By using this one, and you have to ensure they are healthy and not restarting or reporting errors. And also you have to look for the issues with the IP address allocation, or the routing MTU mismatches, or the routing rules. Coming to the fourth one, the DNS6, again the DNS6. Okay, simple here. We have to give the NS lookups. It's completely, it's a networking things I am telling to you guys. You guys might don't know about this NS lookup. IP address allocation, all those things. If you don't know completely about this, we have to copy this and paste it in the Google. You will get it. Because the main question is inspect Kubernetes networks, the network plugins. Here the DNS latency, the check service solution, this is also a network related thing. By using these commands, you can check it. Where it slows down, where the latency is happening, whether it is a DNS latency or service resolution. Check the service resolution as well. Review network policies. We have to once review network because most of them network policies is fine. Okay, if misconfigured, then we have to correct it out. Most of all, we cannot do the misconfigured configuration because before setting the cluster itself only the configuration should be very fine. We have to see very well. And the monitor node and the product resource usage. Same thing. By using our tools, we have to see high CPU and memory. When high CPU are there, high memory are there, or network input and output usage is very high or not. Is there any spikes or not? Okay, all those things we need to see. Check that kubectl top node, top pod, and top node to see if the nodes are overloaded. Consider pod eviction or horizontal horizon. See, I already told you guys. Even the system and everything, everybody will prefer horizontal scaling itself. You have to check the HPA, how it works. Is there any latency happen? Is the CPU memory is high? Is auto scaling happen? Suppose we have to see all the nodes ports whether the CPU or memory or network spikes are there. If they are there, and we have to check the ports if any port is crashed out by using the checking with Prometheus and Grafana as well. So this is one kind of technique we have to do, and we have to trace the network path with tools. This is fine. Network path is always fine. There's no any issues at all. This is also fine. No worries at all. Inspect to the service mesh again. I can tell you right. Service mesh. If there is any latency, you have to run it. Timeout misconfigurations. Too many filters you have to dot for the service, or improper retrace settings. So if you use Istio sidecast, it may cause the latency maybe sometimes, but I never use. But I know the service misconfiguration. By using this, the same thing. You have to write ML, but this is not needed most of the times because your Grafana and if this is find out, Prometheus will find out most of the time. This is also the packet drops in both deep in the networking levels. This is not much required. Okay. And one second. Yeah. Let me go this profile. Yeah. And that's it, sir. That's it, guys. These are all the Kubernetes, main important Kubernetes guys. So we should be. I think it should be very useful for you guys. Prepare well. Get the interview cleared. Get it as a challenge. Get prepared my questions very well, and you will definitely Kubernetes guy. You will be the chomp. You will get it, and you will place it in any of the organization. That's it, guys. All these are the questions. Please go through, and thank you. Thank you for watching my video on my channel. If you like, please subscribe my channel and give a like for my video. Thank you. Thanks a lot. Bye bye.